Hello again, and welcome to Backer Breaks It Down. So, we just derived the formulas for pyramids and cones. Okay, and this is what we came up with. Using the volume of a prism, we were able to discover that the volume of a pyramid is simply 1/3 the volume of a prism. So, volume of a pyramid is 1/3 area of the base times the height. Volume of a cone, very similar. Okay, it's 1/3 the volume of a cylinder. So it is also 1/3 area of the base times the height, but even more specifically, it is 1/3 pi r squared times h. So let's apply these formulas. The Great Pyramid in Giza, Egypt is approximately a square pyramid with the dimensions shown. So it has a square base of 230 meters by 230 meters, and it has a height of 146 meters. The pyramid is composed of stone blocks that are rectangular prisms. An average block has dimensions 1.3 meters by 1.3 meters by 0.7 meters. Approximately how many stone blocks were used to build the pyramid? So what do we need to know in order to figure out how many stone blocks? Okay, I need to know the actual volume of the pyramid, right? I also need to know the actual volume of each block. Once I know these two things, I can simply divide volume of pyramid by the volume of each block, and that will tell me how many blocks it took to build the pyramid. Okay, so volume of a pyramid, I know is found by going 1/3 area of the base times the height. Okay, well, the base of this pyramid can be found by multiplying length times width. So 230 times 230, or simply 230 squared. And then times the height of 146. So the volume of the pyramid, we are looking at a pretty big number. Well, yeah, because we want to take like 1/3 of 7,723. It's a big number. So it's like what, 7,723,400. So 1/3 of that is approximately 2,574,467. Now let's talk about those blocks because we need to find the volume of each block. Now they said that each block is approximately a rectangular prism. So we can find the volume by multiplying the area of the base times the height of our rectangular prisms. So it has dimensions of 1.3 by 1.3. So that would be 1.3 squared for the area of the base times the height, which is 0.7 meters. We're looking at 1.183 for the volume of each of these blocks. So all that's left for us to do is to divide the volume of the pyramid by the volume of each block. And this will actually tell us how many blocks were used in the pyramid. So we end up with 2,176,219 blocks were used. Okay, let's take a look at a cone. All right, so a conical paper cup has the dimensions shown. So we are seeing that it has a diameter of 2.75 inches. And this right here, the 5.5 inches, this is the slant height. Okay, and slant height, we were introduced to that term way back in the first lesson of this chapter when they were talking about like all the parts, of our figures. Okay. Now I need to find volume if I'm going to find fluid ounces, because I'm going to use this conversion factor that 1 cubic inch is equal to 0.554 fluid ounces. Okay, so I do need to know volume. right? And volume of a cone can be found by going 1/3 pi times the radius squared times the height. So if I know the radius squared, well, if I know the radius, if I know the height, boom, I'm done. I know the volume of my cone. They didn't give me either one of these, okay? They gave me the diameter. And so the diameter is twice the radius. So that means the radius would be half of 2.75. So in this problem, my radius of my cup is 1.375. The height of the cone, they didn't give that to me at all. They gave me the slant height, but they didn't give me the height. Remember, the height of a cone is that perpendicular distance from the vertex to the base, okay? So I don't know the height. But since it is the perpendicular distance, I am able to find it because what we have right here is a right triangle. And in this right triangle, I know two sides. And so I can use the Pythagorean theorem to find my third side. So the Pythagorean theorem says the leg squared plus the other leg squared is the hypotenuse squared, or as like everybody knows, a squared plus b squared equals c squared. Okay, so for this problem, that would mean h squared plus 1.375 squared is equal to 5.5 squared. So I do want to solve this for h. Now I'm telling you right now, it isn't going to be a pretty number. I rounded it to two places. So I ended up with that h is approximately 5.33. So now we know our two key pieces to find the volume of our cone. So volume is going to be equal to 1/3 times pi times the radius squared. Remember, the radius is 1.375. And then finally times the height, 5.33. Okay, so I'm going to go and I'm going to throw this into a calculator. And I got approximately 10.55 cubic inches. So that's the volume in terms of cubic inches, but who actually measures volume in cubic inches? I don't. Okay, you look at a can of soda, they use fluid ounces. Yeah, they do. Look. So I need to convert this. So 1 cubic inch is equal to 0.554 fluid ounces. So how much is 10.55 cubic inches equal to? So I'm just going to multiply this by 0.554 fluid ounces, and I'll get my final answer of approximately 5.8 fluid ounces. Okay, and that's the volume of this cup in terms of fluid ounces, right? So 2 more problems to look at, but I'll save that for the next video, right? So here we took a look at an application involving volume of pyramids, and here volume of cones, also featuring converting units. Yeah, they like to do that a lot in this chapter. It's okay. And that's how Becker breaks it down.